All right, here are solutions for perfect problem 2 for Math 251. Basic idea is you're given a function and asked to sketch its derivative. So you're supposed to look at this guy and be able to kind of ballpark what the slope of the tangent line to this graph at any point would be, and then draw a graph whose height represents that slope. So what I'm saying is, I don't know, probably easiest to start with the places where the slope of the tangent line would be 0. If you kind of look, what do we got? Right around here. Let's see how well I can draw. And right around here. And then again down here. The slope of the tangent line at those 3 points would be horizontal, would have a slope of 0. So the height of the derivative at those 3 points should also be 0. So when I draw my graph, it should go through those 3 points. It's kind of a good starting spot. So now all we got to do is kind of connect the dots, I guess. Starting from left to right, if you look here, it looks like the graph is decreasing, really steep actually. It's the slope of the tangent line, it's definitely negative, but it's a large negative number. Hard to tell exactly what it is, but if I were drawing this graph, maybe I'd kind of draw something that's starting out way down here. Well, that's not a great drawing. But it's okay, this is too hard to do. It's getting less and less negative. Note when we get close to this point, it's getting close to 0. So we can just kind of draw this guy. There we go, that's a little better. All right, 3rd time's the charm, although this is like the 5th time. I'm going to draw it like this. I'm going to draw it as kind of a a vertical asymptote at 0. Something like that. Anyways, the slope is 0 here. And then everywhere between these 2 points where the slope is 0, my graph is increasing. So I want to be positive. I want to have a positive height everywhere between those 2 values. It looks like it's increasing the fastest, I don't know, somewhere in here. That's called an inflection point, as we'll learn later. So the highest the graph should ever be would be somewhere in here. How high should it be? I don't know. Slope of the tangent line looks like about 1 to me. But, you know, whatever you think. I guess I would say maybe the slope gets as high as 1 somewhere in here, and then it starts coming down because, well, the slope is still positive. It's not as positive as it used to be. So it's going to kind of come down and head through this point here. And then between these 2 points, it's decreasing the whole way. And again, same idea. It's not decreasing very fast here, but it is decreasing relatively fast somewhere in here in the middle. Almost -1, it looks like, is about as far down as it gets. So I'd kind of try to draw this to look something like that-ish. And then to the right of here, well, let's see, it's increasing. Don't let the fact that the height of this red line is negative confuse you. That means nothing. All you care about is the slope of the tangent line of this red line. And it's increasing the whole way. It looks like it's increasing by more and more. So this should be getting higher and higher. Maybe something like that. So I don't know, I think in blue here we got something that looks like f prime of x. And maybe I'll say for description, for justification, watch video. Ha, that's me being lazy, not wanting to write out my description that I told you guys to write out. But I don't know, good enough. Part B. So what part B wants you to do, I should probably switch colors here, maybe green. Actually for justifications, because I'm going to skip part B also. So in part B, what I want to do is I want to sketch a function. Whoops, it looks like the axis, so there's 0 right there. I want to sketch a function, call it g. And then that function will have the derivative be given by this red graph right here. So what I'm saying is you got to now look at this red graph here, and instead of looking at the slope of the tangent line to this red graph, you want to look at the height of this red line, this red graph. And the height of this red graph will give you the slope of the graph I'm going to draw down here. One other thing I said is start at this point. It turns out you can kind of anchor these graphs wherever you want. So I'm telling everyone to anchor it at 0, 0, just so all of our answers look the same. So I'm going to go through this point, and then what I have to do is look at this red graph and draw the slope of the green graph down here according to the height of the red graph. So what I'm saying is at 0, 0, it looks like the height is a little bit less than 0.5, maybe it's 0.3. What that means is I'm going up, the graph is increasing at that point, but not very fast, only at 0.3, so maybe something like that. So that's at 0. It gets a little bit higher, so it's increasing a little bit faster until we get just past 0. So maybe I'll try that again. It's increasing a little bit faster, and then it starts going down. There's this point at 0.5, so maybe I put that in on my graph. 0.5, 1, and 1.5, and negative 0.5 and negative 1. When I get to 0.5, it looks like the height of my derivative is 0. So at 0.5, this thing should be flat. So I kind of connect the dots looking something like this. And then it's decreasing until I get all the way over here. It's decreasing slowly at first, but then pretty fast when we get a little bit past 1. So I'm decreasing slowly at first, but then pretty fast when I get just past 1. And then when I get just past 1, it's still decreasing until I get over here to 1.3 or so, but it's decreasing less and less fast. In other words, it's concave up, a term that we'll learn later. It's kind of turning around here. And when I get to 1.3, I want it to be flat. And then it starts increasing, and it increases faster and faster. So by the time I get to 1.5, I want it, be increasing pretty quickly. So sure, something like that maybe. So now I just got to draw the left-hand side of this graph. Let's see, everything to the left of 0. Well, I'm positive for a little while here. So what that means is my graph should be increasing for a little while here. But when I get to this point, I want it to be flat. So a little bit to the right of negative 0.5, it's flat. So something like that. And then from negative 1 all the way to negative to that point, it's a negative number. So I want it to be decreasing, and it's the most negative over here. So what I'm saying is I want this thing to be decreasing, kind of fastest in here, and then sort of level off when we get to negative 1. So something more or less like this would be g of x. Your pictures may vary. Maybe I'll even write that. Your pictures will vary. But this is the idea. And then as far as the justification, just write a sentence or two, write whatever you want for A and B. I kind of think they should match up with what I've been saying as I write these things out. So hopefully what I've been saying is good enough for your solutions. So I'm going to leave it just at that and call this the answer, and that's the end.